Let's come to the second part of the question. I have just retained the figure and the math which we did in the first part. Now the second part, we need to find out the refrigerating effect, that is how much heat uh, the evaporator has taken from your food items. So milk and your food items, whatever, how much heat it has taken in this part, okay, from the food items. So basically we need to find out, let's go from the question, the refrigerating effect. We need to find out how much heat it has absorbed by the evaporator. That is, again, evaporator is just like your condenser, and technically it's just doing the reverse thing. It is taking heat from your food items, whereas condenser, it gives out heat to the atmosphere. So heat added to the evaporator is nothing but increase in the enthalpy of the refrigerant, so mass into H1 minus H4. Okay, so that is what is this thing. Now H4 is basically H3, because that's a throttling valve where the enthalpy remains constant, and H3 is nothing but HF at 40 degree Celsius, which is nothing but, we have already used that HF, that is 80 kilojoules per kg. Okay, now coming to H1, how do I calculate H1? Now H1 is somewhere, it's a mixture of both the liquid and the vapor part of refrigerant. So how do I calculate H1? In order to calculate H1, I need to know the dryness fraction. So H1 is basically HF plus X into HFG at your minus 20 degrees Celsius. I know HF, I know HG, so I can use this term, but X, how do I get? So X, in order to calculate X, we need to use the fact that this process is an isentropic process. So isentropic process, the entropy remains constant, as you can see from the figure. It's a vertical straight line, the entropy remains constant. So S1 is S2, S1 is again SF plus X SFG at minus 20, and S2 is nothing but SG at, because it's a vapor at the state 2, SG at 40 degrees Celsius. So we use this fact and we get the dryness fraction, and then we can compute the enthalpy. So SG value is given as 0.67 at 40 degrees, so 0.67, and let's substitute SF is given as your 0.07 at minus 20 degree Celsius, plus the dryness fraction. SFG is SG minus SF, which is 0.7366 minus 0.07. so this is SG minus SF at minus 20 is equal to the SG at 40 degrees. So from this we can easily get dryness fraction, which comes out to be 0.9, and this dryness fraction we need to substitute it here. So this values, HF is basically 20 at minus 20 degrees Celsius into 0.9 dryness fraction just calculated from entropy, and HFG is basically at minus 20, the difference between HG and HF, that is 180 minus 20. So this value comes out to be 164 kilojoules per kg. So 164 kilojoules per kg, and so we know HF now, H4 now. Now come back to what we started for. We started from here. So this value, so because of the space I'm just using here, so 0.025 into H1 just calculated 164, H4 is 80, so this value comes out to be 2.1 kilojoules per second, that is 2.1 kilowatts. So this is the refrigerating effect, basically the heat which is absorbed from your food products and converted into the internal or the enthalpy increase of the refrigerant. So this is what is absorbed by your evaporator inside your fridge, 2.1 kilowatts. So the answer for this is option is A. Option is A, 2.1 kilowatt. Thank you.